Hi everybody, this is the Circle Unit Lesson 12, and today we're going to talk about proofs of various circle theorems. So I've mentioned this before, that the Regents loves to have triangles inside of circles and do a proof with them. So I'm going to show you how these are not too bad at all to do. So we're going to prove a theorem, congruent chords define central angles equal in measure. So AB is a chord, all right, I'm going to trace that. And CD is a chord. So that's my given. My given is AB is congruent to CD. Now, what I want to prove is I want to prove the central angles are equal. So I want to prove that angle AOB and angle COD are congruent to each other. So what I'm going to do is I'm going to first prove that the triangles are congruent, and if the triangles are congruent, then those angles are congruent by Cpctc. All right, so I'm going to start with my given. So statement 1 is that AB is congruent to CD, given. Now I mentioned this earlier, but we weren't doing a proof at the time. All of these lines that I'm now going to draw in blue, AO, BO, CO, and DO, are all congruent to each other. They're congruent because those are all radii of a circle. So AO is congruent to BO, is congruent to CO, is congruent to DO. So all radii in a circle are congruent. And I forgot to mark these, but I already knew that CD was congruent to AB because I knew that the chords were congruent to each other. So basically, those triangles are congruent. So triangle AOB is congruent to triangle COD by side, 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 because I have the three sides. And if the triangles are congruent, then all the corresponding parts are congruent. So angle AOB is congruent to angle COD by Cpctc. Okay, so that's one example of a circle proof. All right, next example, a little bit different. So BC is perpendicular to DE. All right, so this is a right angle in there. FA equals 6. I'm going to put that on my picture. AC is equal to 10. And they want me to find BF, and they want me to find DE. All right, so BF is actually easy. I don't need to do much work for BF. Let me explain why. This right here, AC, is a radius. If AC is a radius and AC equals 10, well, AB is also a radius. AB would have to equal 10. And if the part from A to F is 6, then I would just do 10 minus 6, and BF equals 4. Okay, so that one wasn't bad at all. The next one is a little bit, not hard, but you're going to have to think a little bit. They want me to find DE. DE is this whole segment right there. And they give a little hint, connect A to D. All right, so I'm going to do that. Look at that, that's a radius, so that equals 10 also. Connect A to E. Well, that's another radius, so that equals 10 also. So really, I just have a nice right triangle right there because in the given they told me that those lines were perpendicular. So I can use my Pythagorean theorem in order to find that little piece. So x squared plus 6 squared equals 10 squared. And some of you might know the answer already because we talked about certain combinations that come up over and over again, Pythagorean triples. So x squared plus 6 squared equals 10 squared. X squared plus 36 equals 100. I subtract 36 and I get 64. So x equals 8. All right, so FE is 8. Whoops, I didn't mean to erase that. Sorry about that, guys. Well, this side over here is also 8. because it's the same right triangle, or if you remember, when you have a radius and a chord and they're perpendicular, it cuts that in half. So DE equals 8 plus 8, which is 16. Okay, so those are the two questions that they wanted me to answer. DE is 16 and BF is 4. One last problem, and then we're just going to practice tomorrow. So this is, the arcs are in the ratio. So arc BD is in the ratio of 1. Arc DE is 3. And arc EC is 5. And I should have colored these the same as I was going along. So DE, and the first one was BD. So if they're in the ratio 1 to 3 to 5, it's very simple. All you're going to do is call them 1x, 3x, and 5x. And look, they form a half circle. So 1x plus 3x plus 5x equals 180. Ratio problems are nice and easy. Whatever the ratio is, that's what you're calling those segments. You just tack on an x. So 1x plus 3x plus 5x is 9x. And divide by 9, 180 divided by 9 is 20. So now I'm just going to go back and substitute all these. 1 times 20 is 20. 3 times 20 is 60. And 5 times 20 is 100. So arc BD is 20. Arc DEC, well, that's the green and the blue together. DEC is 60 plus 100, which is 160. And arc ECB, I'll do that in a different color. So ECB is E, C, and then B. So basically it's this half, which is 180, plus the 100, which is 280. Okay, so we'll practice all of those tomorrow in class.